Hello students, welcome back to the chapter Coordination Compounds, and let us discuss the last topic of this chapter, that is application of coordination compounds. To begin with the application, the first one is in the extraction of metals. It is widely used in the extraction of noble metals like silver and gold. Example, in the extraction of silver from its ores. So here is the ore of silver, that is Ag2S, that is sulfide ore, and you have NaCN, that is sodium cyanide, which gives you a coordination compound containing silver in it. When this coordination compound is further treated with zinc will come and replace or substitute silver, and therefore you get a coordination compound containing zinc, and silver is obtained as a precipitate. So the first compound containing Ag as the metal atom is called as sodium dicyanoargentate, but in the next compound it has been replaced by zinc, so it is called as zincate. The next one is in analytical chemistry for qualitative and quantitative analysis. The qualitative detection and the quantitative estimation of metal ions, it can be done with the help of coordination compounds. In the second group of qualitative analysis, cadmium 2+ ions are tested in the presence of copper 2+ ions by the formation of a complex. The solution, which contains both copper and cadmium ions, it is treated with excess of potassium cyanide. When both the ions, they form complexes. Which complexes? Cyano complexes. So here you have copper reacting with Cn, giving you a copper cyano complex. Similarly, cadmium reacting with KCN, giving you a cadmium cyano complex. As we know that copper cyano complex is more stable than cadmium cyano complex, therefore when you pass H2S gas, only cadmium sulfide will be precipitated, and using this we can easily detect the presence of cadmium ions in the presence of copper ions. The next one is the biological importance. Several biologically important natural compounds, they are coordination compounds. The very important example is chlorophyll, which is present in plant, is a coordination compound. Not only this, but even hemoglobin, which is present in blood, is also a coordination compound which contains iron as a metal atom. And then we have vitamin B12, is again a complex of cobalt, is again a coordination compound. The next one is in medicines. The complexes or the coordination compounds have been used in medicine as well. Example is the platinum complex, cis platinum chlorine ammonia, known as cisplatin. It has been found useful in the treatment of cancer. And EDTA, ethylene diamine tetraacetate, is used to treat lead poisoning. The next application is in electroplating for the gold and silver. Since complexes, they are quite stable and dissociate in a solution to a very small extent, therefore they give controlled supply of the metal ions in the solution. This property of coordination compound has been used in the electrolyte in the electroplating of noble metals like silver and gold. The next one is for estimation of hardness of water. Hardness of water is due to the presence of calcium and magnesium ions in it. So when you take hexadentate ligands, that is ethylene diamine tetraacetate, it forms stable complexes with calcium and magnesium, and therefore it can be used for the estimation of hardness of water by simple titration method. And here comes the next one in modifying the redox behavior of metal ions. The redox behavior of a metal ion, it may be modified by complexing it with a particular type of a ligand. Several complex compounds or several coordination compounds, they have been used as catalyst for variety of chemical reaction. The olefins are converted into alcohols by using a coordination compound as a catalyst, and the coordination compound, if you see here, is CO, that is cobalt, and CO, that is carbonyl, which is your ligand, and we have 8 ligands over here. So that is how the coordination compounds can be used for various purposes. That's all for this module and for the chapter as well. Thank you.